Hi everyone. This lesson is on section 1.7 part A. We're actually breaking section 1.7 into two parts. So in part A, we're going to talk about the domain of functions algebraically. So yesterday in section 1.2, we talked about domain being the set of all inputs. Okay, so the set of all x values that make the equation or the function defined, right? And we also talked about to be defined, the expression has to make logical sense, right? And so if you go back to the 1.2 video, I talked about some common operations that cause an expression to be undefined. Those two common operations are division by zero or square roots of negative numbers. And I talked about in section 1.2 why those don't make logical sense, right? So you can go back and check that out. We also talked about how the range was the set of all y values that the graph uses or that you get by plugging in each particular x. Now, when we talked in 1.2 about domain and range, we actually were just looking at finite sets. Finite means that you can count all of the items in the set, okay? But a lot of times we're working with infinite sets, right? Like if we think of the set of counting numbers, 1, 2, 3, 4, 5, 6, that's an infinite set. It goes on forever. Same with our typical set of real numbers, right? Every number on the number line, there are infinitely many real numbers. So when we're working with sets that are infinite, so for infinite sets, we typically express these using interval notation. So we talked about interval notation with parentheses and brackets, starting at the least value, going to the greatest value. We talked about interval notation in section CR5. So if you're not feeling familiar with that, go back to CR5 to review that. All right, so our goal in this section is if I give you a function or an equation of x and y, to be able to find the domain of that function algebraically. So the first thing that we're going to talk about is most functions that we work with have a domain of all real numbers. So you'll see me handwrite the symbol for all real numbers as an R with 2 bars. Okay, so that means our set of all real numbers. Remember, all real numbers are every number that goes on the number line. If we're going to write this in interval notation, we would express it as from negative infinity to positive infinity. Okay, so there's no smallest value, it goes down forever. There's no largest value, it goes up forever. And as we discussed in CR5, we always put parentheses around our infinity symbols. So most of our functions are actually going to have a domain of all real numbers. At this moment in time, there are two possible domain issues, and they actually reference the ones I talked about yesterday in the 1.2 notes. So the two possible domain issues that we're going to look at are division by zero being option 1, and square roots of negatives create undefined expressions being our second issue we're going to look at. All right, so let's first focus on issue number 1. And issue number 1 is that we cannot divide by 0. All right, so if we have a fraction, okay, so anytime we have a fraction, we're going to look for this issue if there's a variable in the denominator. So a fraction like 1/5, the denominator cannot be anything but 5 when we look at 1/5, so no issues. But if I have a fractional expression where there's an x variable in the denominator, then we have potential issues. So our issue is that we cannot divide by 0. So we must exclude all values that make the denominator equal 0. Remember, to exclude means to throw out. So we want to get rid of those values that would make the denominator equal 0. So our process to do this is we find these by setting the denominator equal to 0 and solve. Exclude the answers. So that means when you exclude the answers, the domain is going to be the rest of those things. Okay, so everything else that we didn't exclude, that's going to be the domain. All right, so I'm actually going to jump down to example 3. I'm skipping example 1 and 2 because notice example 1 and 2 are not fractions, right? So they cannot have this issue because there's no fraction. But in example 3, the first thing that you would notice, so this would be your thought process, you would look at this function and you would think this is a fraction. And as soon as you see fraction, you should immediately think the denominator cannot equal 0. Okay, that would be our process for the domain. Okay, so your instructions were to find the domain. So when we see those instructions, you're going to look at this and say, oh, it's a fraction. The denominator cannot be 0. So because we know the denominator can't be 0, what we're going to do is find the excluded values. So what we want to exclude is anything that makes the denominator equal 0. Well, in this expression, the denominator is this piece, right? That's the 2x minus 5 part. So we would say 2x minus 5 equals 0, and we're going to solve this. So I'm going to add 5 to both sides. So this gives us 2x equals 5. Then this is 2 times x. So to undo that, we're going to divide both sides by 2. And so we get x equals 5/2. Now remember, this is the value that we want to exclude. So because my goal is to exclude this, what we're going to do is take this expression and put it on the number line. So on our number line here would be 5/2. And because we're excluding it, we're going to do an open dot at 5/2. We can't have 5/2. So open dot there. However, from up here, the domain is the rest of the stuff. We're going to keep everything else. The only thing x is not allowed to be is this 5/2. So for our domain, we would say that x cannot equal 5/2, but x can equal everything else. And so remember, we're going to express our domain in this interval notation, right? So drawing this on the number line, because x can be anything else, I'm going to shade everything to the right of 5/2, and I'm also going to shade everything to the left of 5/2, because x can be anything except for this 5/2 we're jumping over. So to write our domain in interval notation, we would say the domain is equal to, because this is going down and down and down forever, there's no smallest value. So if there's no smallest, we would use negative infinity, always parentheses around negative infinity. And then I would follow this number line up until I get to 5/2. Now 5/2 is a stopping point. Because 5/2 is an open dot, we would do a parenthesis at 5/2. Now we have to jump over this single point. To jump over it, we're going to do a union, and then we're going to pick back up with things just bigger than 5/2. So we're going to start again at 5/2, parenthesis around 5/2, and then go up to infinity, because after that, this goes on forever. So we would say the domain is negative infinity to 5 halves, union 5 halves to infinity. Now, I want to point out that this is where it's really important that we have a parenthesis on both sides here, because this is saying every number close to 5 halves, but not 5 halves itself. So this is sometimes where it's helpful to just conceptually think about it as a decimal. 5 halves is 2.5, right? So anything below 5 halves, like 2.45, 2.49, 2.4999, right? All of those are very close to 2.5, but actually just below it. So we need up to 5 halves, but not 5 halves itself. Same thing happens on the other side. I need numbers that are just bigger than 5 halves. For example, 2.51 is just bigger. 2.501 is still falling in this just bigger spot. So our parenthesis indicates not 5 halves, but even if it's just a tiny increment bigger than 5 halves, that number is allowed, plus everything bigger. All right, so that would be your answer for example 3, and kind of a little recap of some interval notation there. Remember parentheses if it's an open dot, brackets if it's a closed dot. All right, so let's go back up to, now we've looked at a fraction issue. Let's look at our second issue. So the second issue that could happen is that there is a square root. So I talked about this yesterday. A negative times a negative is always positive. A positive times a positive is always positive. So it doesn't make logical sense for a number to multiply itself and get a negative result. So because negative results don't make sense as a number that was squared, we cannot take the square root of a negative number. So since we cannot take the square root of a negative number, that tells us that a square root must be a positive number. Okay, so the inside of the square root must be positive. So our other way of saying that something's positive is that it is greater than or equal to 0. So to find the domain, what we're going to do is set the inside of the square root expression greater than or equal to 0 and solve. Now, this is what we're keeping. So I just want to emphasize that. Up here, we got rid of what we solved for and we kept the rest. But here in 2, if you have a square root, you're going to keep those particular values. Okay, so you're going to set the inside. I'm going to emphasize this too. We don't actually care about the square root. We want to focus what's inside of it. Okay, so we're going to set the inside greater than or equal to 0. And then solve. And we're going to keep that stuff. All right, so let's go ahead. Notice example 4, I have a square root. So that falls into issue number 2. So when you see these instructions of find the domain, what I want you to think about when you see this is, oh, we have a function right here, and there's a square root. And since we have a square root, that tells us that the inside must be greater than or equal to 0. Okay, so that's your conceptual thought process. When you see these instructions, find the domain, you're going to look at this, notice we have a square root, and conceptually know that whenever you have a square root, the inside of the expression must be greater than or equal to 0. So we're going to solve for our domain this way. So we know inside is greater than or equal to 0. In this case, the inside is everything under the root. If there was stuff outside of the root, it wouldn't matter. We only care about what's under the root. So in this case, that's 2x minus 5 is greater than or equal to 0. All right, so now we're going to solve this inequality. This is one of the reasons in CR5 we specifically talked and practiced solving inequalities, and so you could use that skill here. So to solve this, we're going to add 5 to both sides. We have 2x is greater than or equal to 5. We're going to divide both sides by 2. Divide by 2, divide by 2. 2 is a positive number that we're dividing by, so the sign doesn't change. So x is greater than or equal to 5 halves. All right, if we put this in a number line, this is what we're going to keep. So using that, here would be our number line. We have the number 5 halves. Now, it's a non-strict inequality. It's allowed to equal 5 halves, so we're going to do a closed dot at 5 halves. And then we're going to shade everything greater than or equal to 5 halves. So we would shade everything greater than or equal to 5 halves. All right, so that would be this picture. So our domain as an interval, we would start at our smallest value, which is 5 halves. We're going to do a bracket at 5 halves. And then continue forward. So this would go from 5 halves, and then there's no biggest number after. So we would say this is from 5 halves to infinity. Always parentheses around our infinity symbol. All right, so this would be our domain of this expression, 5 halves to infinity. All right, so at this point, let's go back up and talk about our last fact. So remember, that I said most functions have a domain of all real numbers. Okay, so we're going to look for these two issues. But at this point in time, for the functions we're going to be looking at and seeing in this class, right now, if neither of these two issues show up, so I'm just going to say there are other domain issues we'll talk about later. But for now, if neither of these two issues appear, then you can assume that the domain is all real numbers. Okay? So if neither issue appears, we're just going to say the domain is all real numbers. So example 1 is to find the domain of this expression. So when I'm told to find the domain, I'm going to look at this and ask myself, am I dividing, so creating a fraction? Am I taking the square root? And so when you see this, no fractions with variable denominator, and no square roots. So, because neither of those issues appear, that's going to tell us immediately that the domain of this expression is all real numbers, negative infinity to infinity. Okay? No issues, domain is negative infinity to infinity. All right, go ahead and tell me what the domain of example 2 is. So pause, write it down. So you would look at this. Same thing. When you look at this, we have y equals 5x squared. No fractions. No square roots. So no issues. And since there's no issues, we would say then that the domain is negative infinity to infinity. Okay, so anytime there's no issues, no square roots, no fractions right now, the domain is going to be negative infinity to infinity. All right, so at this point, go ahead and try example 5. You can try example 6 as well. So pause those and try it. And I'm going to go ahead and talk through this. So example 5, my directions say to find the domain. I'm going to look at this expression and I'm going to think we have a square root. So as soon as we have a square root, I know that that means the inside must be greater than or equal to 0. So the inside, when I look at that, the inside of this expression is, notice 6 times the expression. 6 is outside. It's 7 minus x, that's the inside. So this would tell us that 7 minus x, that's what's under the square root. We consider that the inside. All right, so the inside, 7 minus x, is greater than or equal to 0. All right, now this is an inequality that we can solve. So to solve this, I'm going to move the 7 over. Notice this is positive 7, so you're going to move it over by subtracting 7 from both sides. 7 minus 7, that cancels, so we're left with negative x is greater than or equal to 0 minus 7 is negative 7. Finishing solving this, we're going to divide both sides by negative 1. Careful with your inequalities here. This gives you x is less than or equal to negative 7 divided by negative 1 is positive 7. Remember, we flipped the inequality because we divided by a negative on both sides. So I'll just make note of that. Flip inequality because we divided by a negative on both sides. All right, so remember, this is what we're going to keep. So moving up here, if we put this on a number line, my end point is 7. It's going to be a closed dot at 7 because it was an equal to inequality. And we want x less than or equal to. So we're going to shade to the left. That's our less than or equal to, which means our domain, we're going to start at the smallest value. That would be negative infinity because this is going down and down and down and down forever. So negative infinity up to 7, and it was a closed dot at 7, so we would put a bracket here. All right, so this would be the domain of our expression. All right, so let's go ahead and box that. That would be your final answer for example 5. All right, let's look at example 6. So example 6 is special because we have a fraction and a square root. So what we're going to do is find domain for each issue and keep the overlapping interval. Okay, so whenever you have more than one issue happening, you're going to calculate the domain for each respective issue and then keep the overlapping interval. Remember, this overlapping interval, it actually had a name from Sierra 5. This is the intersection. Okay, it's what we did when we had and inequalities. All right, so for the fraction, that tells us that the denominator cannot equal 0. All right, so to find that, we're going to take our denominator and set it equal to 0. So our denominator was the square root of 2x minus 5 equals 0. Well, we have the fact that the square root of 0 is what equals 0. So that tells us that the only way the square root of 0 equals 0 is if the inside 2x minus 5 equals 0. All right, so we're going to add 5 to both sides of this. And we get 2x equals 5. Divide both sides by 2. And x equals 5 halves. All right, remember, this is actually what we're going to exclude. So if we put this on a number line, so I'm going to put my number line right here. So here would be 5 halves. We would do an open dot at 5 halves because it's excluded. And then we can keep everything else. All right, the next thing I'm going to look at is because of the square root, that tells me that the inside must be greater than or equal to 0. All right, so if I look at this square root, the inside here is 2x minus 5. So this tells me 2x minus 5 must be greater than or equal to 0, because that was what was inside our square root. Solving this, we'd add 5 to both sides. So that gives us 2x is greater than or equal to 5. Divide by 2, and we get x is greater than or equal to 5 halves. All right, let's put that on the number line. So here's 5 halves. We want it's equal to 5 halves, so I do a closed dot at 5 halves. And then we want greater than or equal to, so we keep everything bigger. All right, now to find our intersection, we're going to look at the overlapping interval. So what overlaps? Well, none of this is shared because even though I have orange, I don't have blue. Here at 5 halves, even though I have blue, it's open at orange, so none of this is shared. The only thing that's shared is everything above 5 halves. So that would be this section along here that's bigger than 5 halves. All right. And so because we're going to keep this whole section that's bigger than 5 halves, to write that, we can now write our domain. So the domain would be, we'd start at 5 halves. But again, because this orange one was open, it doesn't matter that the blue is closed because we have to keep both. So open at 5 halves, so parenthesis there, up to our overlapping area is going on and on and on forever. And so that would be to infinity. So the domain of this expression is parentheses 5 halves to infinity. We kept the shared interval. All right, so that would be our answer for our domain for this function. All right, guys, that is the end of 1.7a. So please email me if you have any questions, and I will see you in the next video.